Hi, my name is Peter Shields, and on behalf of Hermes Scientific, I'm very pleased to welcome you all to today's webinar, The Benefits of Real-Time Dust Monitoring, presented by Sophia Chew, the Health and Safety Product Specialist from TSI Incorporated. Before we get started, I thought I'd give you a brief introduction to Hermes Scientific. Hermes was established in 1984 and is a market leader in the supply, service and rental of occupational health, safety and environmental monitoring equipment. With offices in Australia and the Philippines, Hermes delivers world-leading technology for a range of applications, including air sampling, dust monitoring, gas detection, and more from international and local suppliers such as TSI. We are also able to offer tailored solutions designed specifically for your local conditions and regulations. Before we cross to Sophia, I'd like to introduce you to Ferdy Lisa, our Philippine sales manager, so he can tell you a little bit about himself. Ferdy?
Thanks, Pete. Hello, my name is Ferdy Leysa. I am the sales manager for Hermes Scientific Philippines. I have been with Hermes for over 2 years and around 20 years experience in environmental and scientific fields. I hold a Bachelor of Science in Chemistry and an MBA, and I look forward to meeting and working with you all in the near future.
I'll now hand over to Sophia Chew, the Health and Safety Product Specialist from TSI Incorporated, who will provide you with more insights on the benefits of real-time dust monitoring. So over to you now, Sophia.
Hi everyone, I'm Sophia, Product Specialist with TSI. I'm based in Singapore. Thanks for joining me today as I walk you through the next hour of photometer technology, fundamentals into real-time dust monitoring, outdoor dust monitoring and advancement, methods currently adopted by the standards, case studies, and how these real-time dust monitors are currently being used in the industry. Okay, before I go into that, I would like to introduce you the current quality standards, guidelines governing this PM 2.5 and PM 10. Airborne particulate matters is regulated by EPA through national ambient air quality standards established by Clean Air Act of 1970s. This allows us to have visibility and access PM 2.5, PM 10 data in the in-countries. For example, for sensitive populations like children, asthmatic, and the elderly, when we have these data available, we know that we are not allowed to enter the outdoor if the pollution is very high, if the PM 2.5 or PM 10 is very high. So we have better access to this information. What about workplace exposure monitoring? For example, activities include crushing, painting, spraying. We have extracted these tables which summarize OSHA exposure limits for some aerosols. The PEL means permissible exposure limits. This is the limit enforced by OSHA. Exposures in excess of this PEL will be cited. TLV, it means threshold limit values. TLV are published and updated by American Conference of Government Industrial Hygienists. These are commonly updated regularly as scientists and researchers know more. So for TLV, definitely are more updated. Because for PEL, changing the PEL is considered rulemaking, which basically follow a very rigid process and inputs from various stakeholders. So the process is slow and of course, often subject to political influence as well. Okay, I'll just like to bring you to some of these common aerosol exposure limits like hexavalent chrome, which is carcinogen. This is typically activities that include welding of metals. And also I'd like to highlight the newly revised silica exposure, which was revised in 2016. You can see the exposure level now has reduced 50% to the previous level. It's like 50 microgram per cubic meter for respirable. So this is definitely much lower than the previous level. Okay, what about indoor air quality? Often we we complain of like stuffy indoor office environment, mucous membranes, itchy eyes, and coughing. But once we are probably step outdoor, we find that we are better. Sometimes this could be sick building syndrome. Okay, so there's definitely guidelines also for indoor air qualities. If you look at some of these listed here, like for PM 2.5, PM 10 as well. Okay, these are extracted from X-ray standard 62.1. This is not the updated version. You can refer to the webpage for more updated version. So what instruments are we using to measure all this PM 2.5, PM 10? Okay. Basically, US federal reference method has been established by EPA to set up consistent methods of measuring PM 2.5 and PM 10 found in fugitive dust. So the methods actually includes reference methods, refers to the left-hand side. Reference method, which specified a high volume sampling pump drawing around 16.67 liters per minute through an impactor with a PM 2.5 cut point deposited onto a pre-weighted 47 millimeter filter media over a 23 to 24 hour sampling time. So this is the requirement. In order to meet federal reference method, the equipment have to prove they are capable to do this. Okay. So definitely 24-hour sampling is required to obtain enough PM on the filter to obtain a measurement. Then after that, the sampling media is dry, weighted, and sent to the lab for analysis. And of course, this is not the real-time monitoring. To minimize the testing burden, the US EPA came up with 3 classes of federal equivalent method: Class 1, Class 2, Class 3. 3 classes of federal equivalent methods are defined based on dissimilarity to the federal reference method. The higher the class, the greater the deviation from the reference method, and requires more extensive testing for equivalency request process. Although the federal equivalent methods can provide data as every 10 minutes for the TEOM, which we call the taper element oscillating microbalance, or the BEM, which is the beta attenuation method. But these equipment are often very heavy, not portable, and of course expensive to own. Okay, so typically Class 1, Class 2, they still follow closely the federal reference method, which they are called the manual methods, using the filter, weigh them, and get a measurement. But for Class 3, it's more of the automated method, which is the TEOM and the BEM. Okay, but again, these equipments are really very heavy, they are expensive, and it's not really portable. So later we will discuss why some customers, they have switched to real-time for such applications. What about workplace exposure monitorings? They are quite similar to the federal reference method, same as they are being, particles are being collected on the filter media and they are being weighed. So for the workers who is performing their work duties, they have to hook up to this sampling pump, filter media, sampling train, which is the tubing connected to the waist, and they have this tubing around the breathing place under the worker's breathing zone. So this will basically measure total dust accumulated during the sampling period, which is easily 8 hours based on NIOSH requirement, OSHA requirement. They have to calibrate the flow before and after as well. And of course, once it's been done for the 8 hours work shift, they will have to remove the filter media, and they have to dry the sampling media, and they have to weigh it, sent to the lab for analysis. And of course, again, this is not real time. They're not able to have any trend analysis. It's only a total dust for that work shift. But again, gravimetric sampling can provide a very accurate and precise sample measurement of the actual aerosols in place. This measure is definitely a total exposure for the day and does not indicate patterns or trends that may occur during the work shift. And after they send the data for analysis and weighing measurements, the data might come back 5 days or 1 week later. And when the data comes back, again, the industrial hygienists, they have to interpret the data, they have to communicate a list of data reports, and they also have to develop corrective action plans if the workers are being overexposed. So again, if their workers are being exposed, they have to do another route of this gravimetric sampling again. So This also means that most of these data there's definitely not enough time to prevent exposure for the workers because most of the work shift has already concluded and you get this data 10 days later. So what about TSI aerosol measurement instruments, or rather light scattering photometers? Light scattering photometers is a category of real-time measurement instruments that are commonly used for occupational workplace exposure monitoring and of course ambient air quality monitoring as well. They are relatively portable. You can see here the desktop version. This is the personal handheld version, and of course the fixed monitoring for the outdoor application as well. It comes in many forms. Okay, and the principle of operation measures the amount of light scattered by the crowd of aerosols. These instruments basically calculate the aerosol mass concentrations based on the known calibrated aerosols. The instrument can vary from true gravimetric measurement, which I mentioned earlier, when the calibration aerosol differs from the aerosol bin measure. That means typically, just now I talked about Federal reference method by using filter media, weighing them. These are definitely more a true, accurate, precise measurement. But light scattering can be very accurate if a certain calibration is being done to the unit. For this reason, that's why the instruments are not used for compliance or reference method. Okay. However, the value of real-time information that I'm going to talk about later brings many great benefits and values to the customers. Okay, so let's talk a little in detail about photometric light scattering. Photometric measures the amount of light scattered by a group of particles. Okay, think of this of measuring how bright the high beams are in the fog, which is shown here. Right, the denser the fog, the brighter the lights are back onto your face. Okay, so basically the photometer uses this brightness and compare it to the brightness of the calibrated aerosol to calculate the mass of the aerosol. The photometer basically sees aerosol of all shapes and sizes. The scattered light is measured and compared to a non-calibrated aerosol in order to calculate the mass. For this, a photometer does not count particles, so do not mistaken a photometer as a particle counter. It's totally different. So a A1 test dust, or we call it Arizona root dust, is commonly used for calibrating light scattering photometers. This is because the this Arizona test dust is a very representative of wind-blown dust and has a very consistent size distribution that closely aligns with the instrument capability. And calibration involves exposing the instruments to a known concentration of this test dust, which is this Arizona test dust, and measuring the photometric response based on the scattered light. And since the properties of the test aerosol are known, which is shown here, size, shape, density, refractive index, size distribution, the mass concentration can be determined and the instrument response can be set, like you set the second hand or the hour hand on the watch, can be precise and repeated. Okay, the aerosol properties just now I mentioned earlier, size, shape, density, refractive index, and size distribution. So, for example, when a sample is taken in a welding shop or construction site or even underground mine, the properties of this aerosol are usually different from the A1 test dust that we calibrate in the lab. The photometer does not know this. So the photometer may not produce the exact aerosol mass measurement unless only the calibration aerosol is present. But again, these instruments can provide precise measurement that is valid indicator of aerosols. The photometers can log data, display the result graphically to indicate trends and high periods of concentrations. And we also have done a lot of in-house testing to test how well they correlate with the reference method and the equivalent methods. So how is this photometric calibration being done? A simple formula is shown here. We call it, some customers call it custom calibration factor. We call it photometric calibration factors. Okay, and it's developed by comparing side-by-side co-locate gravimetric sampling results with the photometric results. So you co-locate both instruments, a reference instruments, and this photometer side-by-side. Okay, TSI has a wide range of these real-time photometric instruments to suit different needs and applications in the field. We have the desktop version, right? It's more for long term, like this desktop version here is more for long term, remote monitoring applications as well. And we even have the handheld, this one. This is the handheld, which is shown here. It's perfect for walkthrough, surveys, single data points, and of course some single data point collection applications as well. Okay, typically this instrument is very lightweight. We also have for personal work area exposure monitoring, we have this side pack, we call it the side pack, which is AM520. It's placed on the worker's waist pouch, and of course the sampling tray is line is placed over the breathing zone to collect particles around the breathing zone. And lately we launched this back in 2015, the environmental monitoring, which is for the outdoor fixed monitoring stations. So let's talk with you on this environmental outdoor fixed monitoring stations. Okay, how is it been done? Okay, fixed sampling equipment is located around 4 points. So we have an event log around this place, which is shown in yellow color, and we have fixed parameter air monitoring around it, 4 points around it. These are usually required to measure the parameter of the event log, which is the source here. The placement of these monitors provide upwind and downwind coverage. Okay, and so another offsite, the purple color shown here, this is an offsite air monitor that's not affected by the construction activities, could sometimes be used as a background reference measurement. Sometimes you can have an offsite unit being placed further away from the event log. Okay. And also oftentimes a meteorological station at site is also used to record temperature, humidity, wind speed, wind direction. Okay. We have developed 3 new models for measuring PM10, which is called Environmental Dust Trap PM10, Environmental Dust Trap PM2.5, and of course EDT DRX, Environmental Dust Trap DRX. DRX is capable of measuring 5 channels at the same time. It's capable of measuring PM1, PM2.5, PM10, and total PM as well. It's just one unit measuring these few channels at the same time. Okay, and this shows internal of that enclosure. We have the it comes with 37mm filter cassette. So for customer who wants to analyze the particles being deposited, they can put in their own filter media. TSI does not supply any filter media, but we do supply this filter cassette. Okay, and of course this is the pump which is located, it's rotary vane pump which is located here. So this unit for the environmental dust track outdoor monitoring is very modular. So sometimes when customer wants to bring this instrument down for cleaning, it's just to remove the box. The photometer is placed here. So the customer just remove the box, they can just clean it in the inlet, or if they just send for yearly calibration, they can remove this box and send it back. They do not have to send the whole enclosure box. Okay, so this is basically the inlet, air coming in, water bottle track to track any condensates and downstream of the unit. Okay, and of course for long-term monitoring in the outdoor application, we want the instruments to run 24/7. We do have few replaceable pump as well. So customer is able to replace the pump if there's issues in the pump, if it breaks down or so. It's pretty fast and easy to remove. Again, the same box, the photometer, you just remove the 4 screw, you're able to access the pump. So everything is very modular, and we, of course, this is we do sell this as a replacement parts. You don't have to send the whole unit back to the to TSI. You can just do it in the field replaceable part. Okay, and this is showing an internal schematic flow diagram of our EDT. Okay, this is a cross-sectional schematic. Air is drawn into the inlet, which you've seen just now, on top of the instrument directly into the optic chamber. So it's drawing around 3 liters per minute of aerosols. Okay, a portion of that will be sectioned off, routed through the HEPA, and sent through optics chamber as shift air. Okay, the shift air is a column of clean air. So once it goes through HEPA, it will come as a column of clean air that surrounds the aerosol, that surrounds this aerosol, incoming aerosol, as it enters through the optic chambers. This shift air helps keep aerosol from sticking to the optics. Okay, and the particles, the aerosol goes downstream. And if customers wants to collect these particles, deposited on the gravimetric filters here. And of course, exhaust through the pump. Okay, this is a new product which I mentioned just now. We launched in 2005. So TSI partner with this Netronics hardware and a wireless service for monitoring dust track data through the cloud. Okay, so how does it really work? Okay, we have this, again, this is a TSI environmental dust track that you've seen earlier. We are able to data log real-time instrument data, and they will streams data to the cloud with this, we call it Netronics 1000 modem. It's a modem. There's an embedded SIM card in this modem. Okay, it streams data to the cloud where facilitating, it has an instrument control. Basically, it can stop the instrument from running. You can view the data online. It has data logging capability. It has a GPS positioning where this instrument is as well. This instrument is located in the north of Philippines or in the south or in Singapore. You can have all these visibilities. Okay, and of course, this Netronics Cloud is a network of data centers that offer reliable and secure operation of the remote monitoring service. The data is encrypted. And last but not least, it comes with Netronics EnviroNet 3 communication management system. You're able to view the data over this web page. And it's a very comprehensive web page. You can analyze the data, you can monitor the data, and of course, you can even use, you can set alarm as well. So this is a complete solution that we provide for the customers. And Netronics is not new to the market. They are really in the market for a while. Their key solution is in the market for monitoring third-party sensors, like here, like TSI third-party sensors. Okay, so it's a complete solution that we provide for the customers. Okay, the features of Netronics, basically the communication ports include RS-485, RS-232, USB port as well, right? And it runs with 3G, Bluetooth, Wi-Fi, Zigbee. So sometimes customers also not only wanted to monitor PM channels, customers also wanted to monitor noise or even NOx, SOx, weather as well. They can hook up all these sensors into the systems. As long as Netronics develop drivers for these sensors, they are able to view this data in EnviroNet. So not only can they view PM data, they can even view all these weather data, NOx, SOx data in the web page, in Netronics web page as well. See how this noise meter or VOC meters are being placed in the enclosure of the dust tracks. Okay, so this is how the web page looks like. If you go to Netronics web page, this is how PM 2.5 or PM 10 data looks like. You can pull them out at the same time, or if you wanted to know NOx, SOx, you have sensors available, you can even pull out data and view them at the same time. Okay, so when I mentioned that you can control the modem, you can turn off the instruments without going to the field, right? You can look when is the last calibration date without going to the field. You can know what's the pump run time as well. So a lot of things you can sit in the office environment without going to the field to actually turn off the unit. So basically, you might have a few units out there in the field in the north, south, Philippines regions. You do not have to physically go down to each site to turn off the unit. Or you don't have to go to each site to physically check the unit. You can look at the status here in the web page. Also, you're able to have that in the Excel table, and you can pull this data out. Just now I mentioned about setting alarm as well. You can set alarm to each individual channels. There's no limit to the number of users. You can set as many users you want. You can set data like PM 2.5, concentration exit 0.05. Please deploy team to the area to mist down the dust. You can set that, and these alarms will trigger to your mobile. So what if those customers are not using this Netronics modem? They can also, currently the instruments EDT can use with our Track Pro software. Track Pro software basically is not real time, but it allows you to do data logging, allows you to view the data trending in the graphic formats and all this. This is TSI software. And of course, you can use EDT with serial commands as well as quick command set. We do have the command set that we can provide to the customer if they want to pull out this into their own systems. Okay, but again, they have to bear that it's not a platform for easy integration of other sensors like noise meters, VOC, and stuff like that. And of course, data access, they can access data through to the web, multitude of a device. Okay, optional accessories include of course, the power options include AC main, rechargeable batteries, or solar panel, depending on customer needs. Okay, and we can do you can also pole mount the unit, or you can do tripod mount as well. Of course, you also have a solar shield that's on top of the enclosure because the unit cannot withstand anything above 50 degrees Celsius. Okay, so we have these optional accessories available for the customer as well. And the power budget for typically this environmental dust trap is very low. The photometer is only drawing 8 watts. The heater inlet is definitely around 13 watts, definitely higher because you need heater to heat it up, so it's definitely higher. But overall, the power consumption is really very, very low. If you are trying to compare that to equivalent methods, definitely that's totally different. Okay, I also like to point out some of the near reference data that we did. This is by comparing our environmental dust trap with EBAM. I think most of you are familiar with EBAM. We call it the beta attenuation method. So you can see that I would like to point out, you can see the relationship for the EBAM. Looking at this graph here, EBAM and our DRX, the R squared value is very close to 1, which also means it has a very strong correlation with the reference instruments. So this means that if I were to put our EDT environmental dust trap out in the field, it can perform exactly like the EBAM. Okay, you can see how well they correlate. The stronger the results are approaching 1, the R squared result approaching 1 means the stronger their relationship. Okay, you can see the pictures here showing our EDT and the EBAM, just located side by side. Okay, next I'm going to discuss in detail on personal exposure limits for workplace monitoring. So just now I mentioned personal exposure limit is conducted by sampling the worker's breathing zone, which is our side pack, which is shown here, connected onto the waist, and the sampling tube is around the breathing zone area. Okay, so how does this real-time benefits workers in the real-time methods are definitely becoming more common because it allows immediate access and reaction to workplace condition, then to wait for the reference sampling method analysis to come back a week later, which I mentioned the data for the gravimetric sampling will definitely come back like 5 days or even a week later, right? So it's like after the work shift has concluded. So this type of real time gives customer a more proactive reactions to the workplace conditions. So if like the dust level is high, they can leave the workplace and come back when the dust level has gone down. So the specs for the side pack is the same. It's a 90 degrees light scattering laser photometers. The detection size range is around 0.1 to 10 micrometer, and the particle concentration range is up to 100 milligram per cubic meter. Of course, there is impactors PM10. If you want to monitor PM10 in the workplace, PM2.5 or PM1 as well. And we also develop a new cyclone, DPM, which is called diesel particulate method, to measure diesel particle exhaust emission at 0.8 micrometers cyclone. So as you can see here, this features for AM520, the side pack, has a very full color OLED screen shown here. This OLED screen is called organic light emitting diode. It basically improves visibility in bright light and even low light conditions. So the screen is very, very clear. And you also have for most of the light scattering photometers, we definitely have audible and visual alarms. Especially for the side pack, we have the alarm is audible alarm and it's pretty loud. It's like 95 dBA because you might be near to a compressor or a pump, right? So this helps you to be reactive to the situation. If it's really overexposed, you might want to leave the work scene. And of course, you also have short-term exposure limit alarm, and you're able to log a separate short-term exposure limit data as well. So real-time instruments have multiple features and advantage for the customers. Just now I mentioned that you can monitor PM2.5, PM1 depending on the impactor that's been placed on the unit. Okay, and we are using impactor oil. Basically impactor oil allows much larger mass loading area and longer sampling times compared to using a grease. Dissolved particle method is a very complex mixture of ultrafine particles and VOC. So we developed a 0.8 micron cut point as recognized as a way to separate out the dissolved particle method from most other aerosols. Okay, so basically in the mining industry, especially underground mines, they have those big tractors, using diesel to run engines. So these ones are key customers for diesel particulate matter monitoring in real time. And these instruments allow you to run a full 8-hour work shift without changing batteries. Okay, it has a 5,400 milliampere hours of lithium-ion batteries, and it's one of the lightest real-time personal aerosol monitor around. It weighs less than 0.7 kg. Okay, so it's very easy to put onto the waist and still continue to do your work shift. So after saying so much, what is exactly the benefits of a real-time monitor? So how do you know the amount of dust and if the existing controls are still working well? Example, filter systems. Is it the filter system still working well? Is the dust control system still working well? So definitely we do need the right equipment to quantify the amounts of dust in the workplace or in the environment. So for example, in your workplace, okay, you may have a dust collector or filter. It's really a good tool to filter or remove those airborne particles. But how do you know if there's a need to upgrade the existing controls or it's time to replace the filters? And nowadays, of course, also nowadays, a lot of filter companies own 1 or 2 dust tracks to quantify to the end user before and after installation of the filter as well, to assess the effectiveness of control measures. So only a real-time instruments can do that. So it would be helpful to know the exposure level, a time indication when the dust exposure level is the highest. So this helps you to better evaluate work tasks and associated dust levels for especially mobile workers throughout their shift, right? To quantify the highest source of dust generation for different tasks. And also to develop controls or improve work practices to reduce mobile workers' dust exposure. So sometimes you might have a new workers coming in. They do not know how to operate the instruments or how to operate the process, so resulting in overexposure. So a real-time instrument is able to teach them. And data logging as well. For real-time instruments, you're able to data log and use software to compare the differences in the change. So the graph provided here shows an example of the mass concentrations reduction that we are looking for. Blue is before the change. So after the change, it has reduced, the dust level has reduced. This is after when you have made the change. Okay, so we're able to compare the data before and after and how much dust level has actually went down. Okay, I would like to draw attention to the revised OSHA silica standard revision. Okay, you can see that occupational exposure limits for respirable silica dust has reduced to, just like I mentioned, 50 microgram per cubic meter, which is now 50% below the previous level. So the ruling states that if the level cannot be met, engineering or workplace controls are required to reduce worker exposure, including providing respirator. So this rule also covers engineering controls, protective clothing, medical, and other issues as well. Okay, so the key provisions actually include reduce the PL for respirable silica to 50 microgram per cubic meter, average over an 8-hour work shift. It requires employers to use engineering controls such as water or ventilation to limit workers' exposure to the dust. Most importantly, also workers need to be trained on work operation that results in silica exposure and ways to limit exposure. Also keep records of worker silica exposure as well. So only a real-time instrument is able to do that, to train the workers how to limit the dust exposure in their workplace. Or if their existing dust control works still currently working well. The next is also revision to list respirable silica on the general industry and marine time. You can see a list of industry sector here. So workers currently exposed, there are plenty of them. And now workers have to bear and take note of the new revision level now. So all these new standards definitely demand a real-time solution to dust monitoring. It's definitely an easy tool to train your workers. if the dust control methods they use is effective, because you can see the result instantly, indicative result. So to sum it up, real-time dust monitoring is the preferred choice because it allows customers to do the following: to check that exposure limits are not exceeded, and to check that your existing control works well. Or if you need a better one, for example, your filter is not working anymore. So if you need a new filter, you need to change out the filter. Also, it allows time indication when the concentration of a level of dust is the highest. So it allows you to pinpoint the work activities occur at that time, or is it a new worker who does not know how to operate the process. A new control method works better means it could be a validation method. Okay, so dust track can be used for a validation method if this existing dust control works well, or after the process change, the dust level might change again. So it can be used for a validation method. Need for health respirator, area health protection, right? If your worker is being overly exposed, the last resort is always to use a respirator. But he has to make sure that he has done all the dust control levels down in the workplace before he's given a respirator. So of course, a tool using real time to train your worker how to reduce exposure instantly. Last but not least, a data record which allow customers to do analysis. Just now I showed about the can put that in a graphical format to analyze the data at what time, when the dust level is the highest. Okay, so I hope this real-time dust monitoring really brings benefit to you as a customers, because you can always have different options available for your needs and applications. Okay, thank you. This is the last of our presentation slides. Peter, I'll hand this over to you.
Thanks very much, Sophia. Hope you all found it useful and interesting. We appreciate the insights you provided into the benefits of real-time dust monitoring. So thanks very much, Sophia.